Hello, today I'd like to talk to you about a comprehensive digital twin including wire harness manufacturing. My name is Nigel Hughes and I'm responsible for product management for Siemens electrical tools within Integrated Electrical Systems, or IES. Capital's focus overall is at EE systems development, starting at the very beginning with requirements and models, flowing through initial architectural and petitioning decisions, and generating then the relevant software, network architectures, electrical distribution architectures, as well as specifications for components in those networks, before moving on into the engineering domains to develop that software, to specify those networks and provide ultimately implementations that will run on the vehicle, as well as then the implementation of the electrical distribution system down there in the bottom half that will require the manufacture of harnesses which will form the nervous system of the vehicle, communicating all of those signals that the software is generating. All of this is wrapped in a continuous verification and validation process and is integrated with the product lifecycle management systems, the MCAD data that form the physical constraints for the electrical distribution systems, with a range of other complementary Siemens products. But as I said, today we'll be focusing on harness engineering and specifically the manufacturing and how those harnesses are actually produced so they can be installed on the vehicle. Across all of the core markets for harness manufacturers, the needs are really the same, whether it's agricultural, automotive, aerospace, commercial or defense. There is constant pressure to reduce cost and schedule. The complexity of the content is going up year on year, and the variation within a single product line increases relentlessly. This is being driven by the next trend, by the increasing electrification of products, driving more and more of the distinguishing features of a vehicle into the EE domain. And then, of course, finally, we live in an increasingly globalized economy where we can look for options for optimized manufacturing processes based on an entire globe of opportunity for different labor markets and those kinds of things. And so Siemens and Capital sets out to deliver a comprehensive digital twin connected by a consistent digital thread across all of the different elements of that comprehensive twin. So for the product, that's where we tend to be more comfortable or familiar with a digital twin as we build the model of the product. But we also wish to build the model of how that product is made, and that enables us to optimize and streamline the manufacture of electrical harnesses. And then finally, the products don't cease to exist as they go out into the world. That twin needs to extend to cover how those products are used, as well as a feedback loop that carries data back into the previous two stages in a spirit of continual improvement. So none of these pain points are going to go away. None of the trends are taking us away from these challenges, and everything highlighted there is what we need to deliver. And that's very much our mission, to support our customers as they try and overcome these challenges. And we can do that by automatically generating that bill of process using assets such as part libraries, rules and constraints, and other IP within an organization that lets us build both the digital twin that's encompassing the product, the engineered product models, as well as the validated models of process in addition. And out of this, by using that model of the physical product as well as the model of the process, we can automatically generate a bill of process and all of these different outputs which are needed to then drive the actual production process. And of course, our vision is, as we go into the actual production process, that we can carry that back in that process of continual improvement. And by carrying this back, as where even the intellectual property and methodologies we use to manufacture and describe our products are captured digitally, this enables us to have configurable styling and visualization, capabilities like automatic part selection, customizable rules and checks, and the ability to validate and manage change transparently. And we can carry all of that expertise into the manufacturing process as well, with reusable process modeling, and then the ability to generate then, not this time the product, but the structured bill of process and bill of materials that is required in order to manufacture that harness, with all of the attendant costs and estimations required to ensure that this very tight margin business is able to be profitable and bring value both to the harness manufacturers' customers and themselves, and achieve through this continual improvements in efficiency with items like automatic work instruction generation. So if we can do this, how do we validate and optimize this process? It takes a really long time to set up a factory. So how can we do this? And of course the answer is we do this with the digital twin that we've built of both the product and the process in a feedback loop. So I'd like to give you a little bit of an oversight about how we're able to achieve this. So what you've seen there is it's possible to take our digital twin and bring it to life, simulating the actual factory and the operations going on, enabling us to perform all kinds of validations, analyses, and checks. We are also able to take that digital product or digital process and validate and explore different alternatives so we can better understand and find new ways of manufacturing and maximizing the resources that we have, and essentially then enable us to optimize production in a virtual environment before we've even begun to rearrange the shop floor for a specific harness. What we've seen today is that by including production as part of a comprehensive digital twin, we're able to reduce ramp-up times for new production lines, improve quality and efficiency, as well as overall productivity and throughput, removing bottlenecks. And so thank you very much for your attention, and please let me know if there are any questions.